Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is Vitamath 33, and in this video I'm going to derive the law of sines and law of cosines, although you know this already. So derive the law of sines and cosines and one area of a triangle in terms of a single side and two interior angles. So we have this triangle here. All angles A and C are acute. Then we have another triangle where one angle is obtuse. Angle C is obtuse. Then we draw a line perpendicular to side B, and that is 8 sub B. So that's also 8 sub B. Then perpendicular to C would be 8 sub C, perpendicular to A, that would be 8 sub A. So before we proceed, remember that in any triangle, the sum of the shorter sides should be greater than the longest side. So in this case, B is the longest side, and A and C are the shorter sides, so the sum of A and C should be greater than the longest side. So in fact, if you project C, if you strike an arc, that is C, and this is A, they overlap, and obviously A plus C, the shorter sides, the sum of the shorter sides should be greater than B. In this case, C is the longest, but B plus A, which is also long, will be definitely greater than C. That's why a triangle is formed. So again, in any triangle, the sum of the shorter sides is always greater than the longest side. So that uh, if the sides of the triangle are given, you have to evaluate this equation here because there may be no triangle that can form. So always bear in mind that the sum of the shorter side should be greater than the longest side. Secondly, the biggest interior angle is opposite the longest side, and the smallest interior angle is opposite the shortest side. And if you look at here, C is the shortest, that's why angle C is the smallest interior angle. B is the longest, that's why angle B is the biggest interior angle. In this case, A is the shortest side, so A is the smallest angle. C is the longest, that's why C is the biggest angle here. In fact, it is an obtuse angle. So from the figure, HB is in this right triangle here. HB equals C sine angle A. By the way, when you want to draw a triangle of known sides and accurate, no? When you want to draw accurately triangle with the given sides, all you have to do is first lay out the longest side, let us say B. Then with A as center of the circle, strike an arc with radius C. Then with C as center, strike an arc with radius A. The two arcs will meet at point B, and the triangle is now formed with exact dimensions, with the actual dimensions. So that's the geometric technique in constructing a triangle. So that if you're going to estimate the angle, all you have to do is fit a protractor here, then you can estimate the angle. Actually, you can use the geometric technique drawing in answering many questions in geometry. Even the radius of the circumscribing circle, the radius of the inscribed circle in a triangle, the perpendicular, the angles, whatsoever. you can use that technique. So you bring a protractor, you bring a compass in striking an arc, then a scale also, ruler. You can have that. So again, HB is C sine angle A, and in this right triangle, it is also A sine angle C. So the law of sines, HB is C sine angle A. It is also A sine angle C because HB is opposite. Then in this case, HB is equal to C sine angle A, which is this, it's the same, and it is equal to A sine of this angle. So if this angle is angle C, then this angle is 180 degrees minus angle C. So if, that is also H sub C through C. So again, HB is also A sine of this angle, 180 degrees minus C. But remember that sine of quantity 180 degrees minus C is the same as sine of C itself. So this goes back or reduces to this same equation here. So HB is A sine angle C. Then equating HB here, by the way, for this case, H sub C is hypotenuse B sine angle A, and it is equal to A hypotenuse sine angle B. So H sub C is B sine angle A. It is also from this right triangle, H sub C is opposite to this angle. This is the hypotenuse, so A sine angle B. So it is also A sine angle B. From this equation, equating HB, so we have C sine angle A equals A sine angle C. Then rearranging C over sine angle C equals A over sine angle A. Likewise, equating H sub C, so we have B sine angle A equals A sine angle B. So from this equation, C over sine angle C equals A over sine angle A. From this equation, B over sine angle B equals A over sine angle A. So A over sine angle A equals B over sine angle B. But since A over sine angle A is also C over sine angle C, then we can now derive the law of sines as a continuous equation. And remember that from the preceding Vitamath problems, we showed that the ratio of any side of a triangle to sine of the angle opposite it is constant, and that constant ratio is the diameter of the circumscribing circle, or 2r. Therefore, A over sine angle A equals B over sine angle B equals C over sine angle C equals 2r, the diameter of the circumscribing circle. This is the law of sines. And in this law of sines, there is an ambiguous case. As a reminder, make sure that you solve, if you want to solve for the angle, make sure that that angle should be, uh, the angle should be acute angles. So opposite to shorter side should be solved first if you solve the law of sines. The purpose of that is to make sure that these angles are acute. Because if you solve the biggest angle first, your calculator is designed to answer acute angles only. It is not capable of answering obtuse angle unless you use the law of cosines, because the law of cosines is an absolute law, absolute formula. There's no situation where it will give us a wrong answer. So again, my suggestion, and as a reminder to all of my subscribers and viewers, to get rid of the ambiguous case, my suggestion is, if all sides are known and one angle is known, for example, so that you can use the law of sines, make sure that you solve the smaller angles first, because they are definitely acute angles. Do not solve the angle which is opposite to the longest side using the law of sines because it might be an obtuse angle. So if you use law of sines uh, solely, then you have to check angles A, B plus C should be equal to 180 degrees. Otherwise, if the sum will not yield 180 degrees, it means one of the angles there, especially the one that is opposite the longest side, is obtuse. So that is my suggestion as a reminder to get rid of the ambiguous case. So let's proceed to the law of cosines. So let's denote this side as x, and therefore this other side of this right triangle would be b minus x. From this right triangle, hb squared by Pythagoras theorem is c squared minus x squared. And by the way, in this triangle here, let's call this y. So let's have this triangle first. hb squared equals c squared minus x squared, and hb squared is also a squared minus quantity b minus x quantity squared. So hb squared equals c squared minus x squared, the law of cosines, and it is also a squared minus quantity b minus x squared. So expanding the right side, c squared minus x squared equals a squared minus quantity b squared minus 2bx plus x squared. So that's algebra. Then remove grouping symbol, c squared minus x squared equals a squared minus b squared plus 2bx minus x squared. Then we can cancel negative x squared here and transpose negative b squared to the left, 2bx to the left. So this becomes b squared plus c squared minus 2bx equals a squared. And from this equation, x is, from this right triangle, x is c cosine of angle A. So x is c cosine angle A, substitute here, but I'll first write a squared. So a squared equals b squared plus c squared minus 2bx, and x is c cosine angle A. And that is now one of the equations in the law of cosines. So a squared equals b squared plus c squared minus 2bc cosine angle A. So likewise, in this triangle here, hb square is equal to c square minus quantity b plus y square, and hb square is also, from this right triangle, a square minus y square. So hb square equals c square minus quantity b plus y square. It is also a square minus y square. So let's expand this part. C square minus quantity b square plus 2by plus y square equals a square minus y square. Let's remove this parenthesis. C square minus b square minus 2by minus y square equals a square minus y square. So we can remove negative y square by additive inverse and transpose b squared to the right, leave c squared here, and negative 2by to the right, so it becomes positive. So c squared equals a squared plus b squared plus 2by. And y, from this triangle here, remember this angle is 180 degrees minus c. So y is a cosine of 180 degrees minus c. And cosine of 180 degrees minus c is equal to negative a cosine c, because the expansion is cosine of 180, which is negative 1, times cosine of c. So negative 1 times cosine of c is negative cosine c, plus sine of 180 degrees, which is 0, times sine of c. So 0 times sine of c, that is 0. So it is cosine of 180 degrees minus c is negative cosine c times a, so negative a cosine c. Substitute here. So c squared equals a squared plus b squared plus 2b times negative a cosine c. So we can now derive the last equation of the law of cosines, but by deductive reasoning, by following this pattern, then b square is equal to a square plus c square minus 2ac cosine angle b. So b square equals a square plus c square minus 2ac cosine angle b. And from this equation, c square equals a square plus b square minus 2ab cosine angle c. So these are the equations of the law of cosines. We have just derived the law of sines and the law of cosines. So remember that there's no problem with the law of cosines. There's no ambiguous case for this case if you apply this. So just make sure that the triangles are uh, the given sides are legitimate by applying this principle here that the sum of the shorter sides is greater than the longest side. Then for the area of the triangle, 1/2 base times height in general. So it is 1/2 a times HA, where HA is the altitude through vertex A. It is also 1/2 B times HB, just like this, 1/2 B times HB, and it is also 1/2 of C times H sub C. So where HA, HB, and H sub C are the altitudes through vertices A, B, and C respectively. Then, since we are required to derive the area of a triangle in terms of one side and two angles, actually if the two angles are known, then automatic the third angle will also be known because the sum of the interior angles of a triangle is 180 degrees. So it is the third angle should be 180 minus the sum of the two given angles. So area in particular is 1/2 B times HB, where HB is equal to C sine angle A. So 1/2 of B times C sine angle A. Remember that the area of the triangle also is 1/2 the product of adjacent sides B and C sine angle A. So it is also 1/2 AB sine angle C, 1/2 AC sine angle B, just to review. So 1/2 of the area of triangle is 1/2 the product of adjacent sides times sine of the angle included. So that's the way how to remember area of triangle in terms of adjacent sides and the angle between the two sides. Then from this formula C, from this law of sines, C is equal to, so that it will be in terms of one side only, B. So C is B sine angle C over sine angle B. So let's replace C here by B sine angle C over sine angle B. Area of triangle is 1/2 B times quantity B sine angle C over sine angle B, then times sine angle A. So finally, the area of a triangle in terms of one side, if we start with A squared, let's follow this pattern, is A square, if we choose A as the first side, so A square, then these angles here, product of angles adjacent to that side A. Adjacent to side A are B and C. So A square sine B sine C, then this angle here is the angle opposite to this side here. So if you use A square, area of triangle is A square sine angle B sine angle C over 2 sine angle A. So I hope you can simply recognize that or pattern that from here. So this is the second formula, B square sine angle A sine angle C, where A and C are angles adjacent to B, then divided by 2 sine angle B, where B is the angle opposite to that side B. So area of triangle is also B square sine angle A sine angle C over 2 sine angle B. Then finally, in terms of side C, C square sine angle A sine angle B over 2 sine angle C. So that's the area of triangle. Just familiar one. Take note also that this angle here is the third angle, and it is equal to 180 degrees minus the sum of B and C. So A is 180 degrees minus the angles B plus C. And remember that sine of 180 degrees minus quantity B plus C is equal to sine of A itself. So take note that sine of C is sine of 180 degrees minus angle A plus B. And remember that sine of 180 degrees minus something is sine of something. So that means that this side C here, angle C here, can be replaced by sine of A plus B. Because sine of 180 degrees minus quantity A plus B is sine angle C. And sine of 180 degrees minus quantity A plus B, remember sine 180 degrees minus something, let us say theta, is sine of theta itself. So therefore, if we denote this A plus B as theta, you can replace C by quantity A plus B. So that's it. That's the original formula, but I just put it C here, B here, A here, so that the area formula would be compact. So that's it for this video, and I hope that your knowledge is improving, and I hope that you can solve problems in trigonometry applying the law of sines and cosines, especially special mentioned with the law of sines because of there is an ambiguous case. My suggestion is you have to solve for angles, if it is the angle that should be computed, that are surely acute by solving angles opposite to the shorter sides. Use, if you can apply the law of cosines in computing the biggest angle, then do it. There is a big possibility that it will be obtuse. If it is acute, then therefore the other angles will also be acute. If the biggest angle expected using the law of cosine, there's no problem with this, is acute, then the remaining angles will also be acute. Always, because we solved the, or you solved the biggest interior angle.